Welcome. NOAA has just released its Global Climate Report for December of 2022 and for the entire year 2022. And this video is a summary of that report. Well, what are we going to cover today? Well, first of all, the overall year was the sixth hottest on record, as I've been predicting for several months now, with an average temperature of 0.89 degrees centigrade above the 20th century average. Now, you should remember that the 20th century has quite a lot of global warming in it already, particularly the last 30 years. This is despite the fact that La Nina has dominated for most of the year. La Nina is a cooling of the eastern Pacific, which has a great deal of influence on the global climate. Sea ices continue to retreat at a rate of about 2% per decade. Global cyclone activity was at or slightly below average for the year. Carbon dioxide content in the atmosphere passed 420 parts per million. I've included here some information about solar activity because some people like to link solar activity with global climate, which is generally false. Solar activity has been declining for the last 30 or 40 years, and this has led some people to believe that we're heading into a grand solar minimum and thus a new little ice age. It turns out the solar cycle 25 is growing quite rapidly and will obviously outperform solar cycle 24 and thus reverse this trend of declining solar cycles. And so that will hopefully be the end of all this talk of grand solar minima. Well, let's take a look at the graph from NOAA of the annual temperatures. This is the combination of land and ocean. And you can see that 2022 was indeed the sixth warmest year on record. In fact, 10 of the hottest years have all occurred since 2010. That's that dashed line across the plot, which would make this the warmest decade in the last 150 or more years. Now, going back to 1850 was the end of the Little Ice Age, so you could probably make a reasonable claim that this was the warmest decade since the 13th century. And it may well go further back yet than that, from the point of view that this temperatures now are probably rivaling, if not exceeding, the Holocene climatic optimum from 7,000 years ago. So we may have to go back to the previous interglacial period to look for a temperature that is as warm as we're having today. So you can't say that this is just something normal or natural that's going on. This is something exceptional going on, and we need to remember that when we're talking about this subject. Here is the list of the hottest years on record ordered by the temperature. So where is all the heating occurring? Well, just about everywhere. The only area here that's blue, which indicates below average temperatures, is the Eastern Pacific, and that's the signature of La Nina. All the rest of the planet is above average, much above average, or record warm. That's the deep red, and there's quite a lot of that. Unfortunately, the phenomena of El Nino and La Nina affect global temperatures quite significantly. And so we'd like to know what's happening to global temperatures if we can remove those effects. Well, how can we do that? What I do is I look up the Southern Oscillation Index for the most recent month, in this case December of 2022, and go back and find all the months over the last 70 years that had a similar Southern Oscillation Index and plot that as a function of time. So this is effectively taking out the effects of El Nino or La Nina. And you can see that there is a distinct increase in temperature over time. And in fact, if anything, it is actually accelerating. So we are seeing warming, and this is not associated with El Nino or La Nina. This is the natural climate warming. And that's what we've got to be worried about. Changing temperatures is only one aspect of climate change. Here I'm showing the precipitation changes. Brown indicates drought, blue indicates floods. So you can see that, for example, the central US and western states of the US have been subject to drought, as has most of Europe, whereas places like Australia and Pakistan have had excessive rains. El Nino and La Nina affect the rainfall in many different parts of the world. So the question is, how long is this La Nina going to be with us? It's been with us for the better part of 3 years. This is a plot of the model of how El Nino and La Nina are evolving. Anything below the line is a La Nina, anything above the line is an El Nino. And you can see at the moment we're well entrenched in La Nina, but the trend is towards a warming of the Eastern Pacific, i.e. we're going to go to what's called an ENSO neutral round about February or March of this year, and possibly get into an El Nino sometime in the middle to the late part of the year. And we can expect temperatures to rise as a result of that. So how did various continents fare as far as temperatures are concerned? Let's take a look. North America was the 15th hottest year on record. Europe the second, as was Asia. Australia's was the 20th warmest, or that's actually, I believe, what's called Oceania. Africa was the 10th warmest, and South America the 12th warmest. With rising temperature, sea levels continue to rise. The glacier melt is accelerating. Look at this difference in this glacier in just 1 year, how much it's retreated. In fact, you can compare here what's happening with both Antarctica and Greenland. Greenland has been melting more rapidly because it's closer to the equator, but even Antarctica has been showing signs of significant melting. All of that contributes to sea level rise. If you look at the ocean heat content, there's been quite a change over the last few years. The hotter the oceans are, the more they expand and sea level rises. The greatest effect is near the surface, the top 2,000 feet or so. Moderate depths, there is still a temperature rise, but by not so much. And in the greatest depths, even below 6,000 feet, there is still a distinctly significant increase in the temperature and therefore the expansion of the oceans. So what has this resulted in as far as sea level rise is concerned? We have an increase of over 50 millimeters from 1993 to 2008, and more recent data shows there might even be an acceleration of that rate in the last few years. Another important aspect of climate change are cyclones. Hurricanes in the Atlantic Ocean and Eastern Pacific, typhoons in the Western Pacific, and cyclones in the Indian Ocean. And here I've got a table of the number of events in each of the districts, the number of storms, the number of cyclones that resulted. About half of the tropical storms turned into cyclones. The number of deaths reported, which this year nearly reached 1,000, and the cost, which was over $178 billion. Now, this was a season that was actually at or slightly below average in most areas. Here are some images of those major cyclones. This is mainly from the Atlantic Basin and the Eastern Pacific. Here I have put the temperature record data for the globe broken out into land and ocean and also by hemisphere. And you can see they're all in the range of 6th and 7th ranked through over the last 150 years or so. Here is the situation as far as carbon dioxide is concerned. You can see the annual variability is continuing as normal. The overall trend is up as usual. There's been a few dips here and there associated with COVID-19, but we're still continuing an upward trend. Over the year, we have had an increase of 2.2 parts per million in carbon dioxide. That is quite normal. And we can take a look at how this stacks up over time. This is a very detailed plot of carbon dioxide as a function of time. Let's put in our current level at 420 parts per million. And you can see we can go back to over 20 million years before our current level was exceeded. We should not forget that carbon dioxide is not the only greenhouse gas. The increase in carbon dioxide is largely due to the burning of fossil fuels and the production of concrete. But we also have methane, which is from the rotting of wood and also landfills and cattle. That paused at the beginning of the 21st century, but is now starting to accelerate back up again. Nitrous oxide is largely due to farming, and that is from fertilizers and such like, and the increase there seems to be fairly linear. Although there's an interesting sort of oscillation imposed upon the top of that. Then we also have sulfur hexafluoride, which is increasing as well. Well, is the sun a factor in this climate change? I would argue not. This is a model of what's happening for solar cycle 25, the red line. The data here shows what's actually been observed so far. Solar cycle 24 was a modest cycle, below average cycle, and the panel predicted a solar cycle 25 that would be similar, but perhaps slightly larger. However, the sun is fooling us again and has produced a lot more activity than was originally forecast. And you can see we're exceeding this level by nearly a factor of 2. That would mean a very much larger solar cycle coming up in the next few years. And that would break the trend of decreasing sunspot number for solar maximum that has occurred over the last 4 cycles. And that should end all this discussion of a grand solar minimum. The reason why I can say that solar activity is not really affecting global temperatures is this graph here. In red, we show the global temperature plotted as a function of time since 1880. And in yellow, we have the smooth sunspot number plotted over the same period. Both of these are averaged over an 11-year cycle. And you can see for the last 40 to 50 years, the two have been in an exact opposite trend to one another. The solar activity has been decreasing, global temperatures have been increasing. All these predictions are also well and good, but we don't actually know what's going to happen, and there are factors that can change these predictions quite radically. One would be a major volcanic eruption. Is there another Tambora waiting for us in the next decade or so? In which case that would depress global temperatures quite significantly. And then there's regression into another long-term La Nina. Instead of going to an El Nino as predicted, the climate could fool us and drop back into another La Nina, and we'd be back into the same cooling cycles we've been before. So what conclusions can we draw from all of this? 2022 continued the run of warming years that has characterized the past decade or so. That trend is likely to continue into 2023 and beyond. The loss of glaciers and warming of the oceans will cause sea levels to rise even faster, and extreme weather events will get more frequent and deadly. So that's it for 2022. Look forward to seeing what happens in 2023. So until then, stay safe and goodbye.